perform any operations on variables, like variables we have discussed earlier, right? Type variable name, some 10. So this we call it as a name. This will be like data type, any data type. So this variable name cannot be a keyword. So like now I have int num equal to 10, string name, like this. We have to define the data type and the variable name and the data. So either we can initialize at the same time or we can initialize it later. Like,
Hello,
yep,
hello, sir.
yep.
Sorry to interrupt, but we can't see your screen.
Oh, sorry. Okay. Is it visible now?
Yes, sir.
My bad. I was not checking that one. Okay. Anyhow, today we are gonna cover again. I will tell. Like I think here we can go previous. So we have operators, Boolean, conditional statements. Like to check to make a decision, we have to know in program what we will do, how we take a decision in a program. That we can proceed by using conditional statements. We call it as if else and switch. And loops to do the repetitive work. In loops, we have entry control and exit control. Entry control is like for loop and while loop. Exit control is like do while loop. We have seen some practical examples yesterday. And we have break and continue statements and where we will use. And we have strings, like we have earlier we have discussed like char statements. Char equal to something like this. So character data type can allow only one element at a time. And that too it should be in a denoted in a single quotation. And we have a string also. String is like to store multiple characters in a single variable. Like, so string we should define in a double quotes. So now this variable can store this complete string in a single variable name. Okay. Now we will check the operators. So C divides, in C we have like operators are divided into multiple sections. One section we call it as arithmetic operators. We have arithmetic operators, and next this we have seen yesterday, like plus, minus, multiplication, division, and modulo operator, and some of the plus plus, which is increment, and minus minus, which is decrement. These are like arithmetic operators. And we have assignment operators. Assignment operators as in like equal to. There are many other assignment operators also, like equal to, plus. This is nothing but, so we talk about right left hand and right side. This is so like now I have like num. Yesterday we did some sum values like sum equal to sum plus number. Okay, so the same thing can be converted like this, which is basically nothing but the same about. So this will be divided like this. Okay, so let's take x plus equal to 3. It will be converted into x equal to x plus 3. Again we have minus equal to, right? So if it is x minus equal to 3, it will be like x equal to x minus 3. So here what we are doing is like the same number will be added with the number whichever is available on the right side and assigned back to the same variable. That's what these way operators means. Same thing, same arithmetic operators. Like we have equal to, right? When an arithmetic operator is clubbed with an assignment operator which is equal to, it will be treated as like this, like minus. So we have plus, right? So plus equal to, it will be treated like this, like left hand side element plus left hand plus right side element. Minus equal to same thing again, left hand side element equal to left hand side element minus right side element. Again we have another arithmetic operator called multiplication. This will be converted like this, right side element, like this. So these are the assignment operators we have. So the same arithmetic operator clubbed with equal to will become an assignment operator, which is the formula of that one is like this one. Left hand side element, like whenever we define left hand side one element, one arithmetic operator equal to and assignment operator some right side element. This will be converted like this. Okay. Again, we have other assignment operators also, like with included with logical operators and bitwise operators. Left shift and right shift. This you might have seen in like DLD and some other courses. So this we'll check later. Okay. So arithmetic operator plus assignment operator will become assignment operator. So that will looks like this. This can be converted into. Okay. Next we have comparison operators. So comparison. So we said decision we have to make, right? Which is greater than or like 5 is greater than or 3 is greater than or 4 is greater than or 6 is greater than. Whatever these mathematical operations, we should know we have this less than, equal to and everything. The same is converted in the form of operators in C language, and the same will be converted in Java language also. The same operator will be used in Java also. So if usually in mathematics we check equal to, right? Whether if it is equal to or not, like that. So but here we will check with double equal to. This will become whether left side element is equal to the right side element or not. If it is true, it will return 1. we have not equal to. This symbol is not. We have not equal to, greater than, less than. We have usually will in our maths will greater than or equal to will be like this, but in program the same will be converted like this, greater than or equal to, and less than or equal to will be converted less than or equal to. This if it is matching, it will return 1, else it will return 0. The same is like treated as 1 is true and 0 is false. So these comparison operators will return a integer value if it is success, and it will return 0 value if it is not success. So now I have a scenario where the provided element should get an element which is greater than 5 and less than 10. So for in those scenarios, what we should check, like we have like logical operators, it should be the number given should be greater than 5 and should be less than 10. So like this, and or, and some case like it should be either less than 5 or it should be greater than 10. Those elements only we want. We don't need elements between 5 and 10. So like this, if we want to achieve in program, we have called logical operators. Those are nothing but and. This double ampersand we call it as and there is a confusion here, like single ampersand is a bitwise operator. It should, whenever we are comparing between two elements like x less than 5 and x less than 10, in these scenarios this is like an logical operator, and we have or. Usually in programmatic in real mathematics we use this one and or like this in sets, if you remember. So here we use double ampersand for and double slash for or, and logical not to negate. Like we have this scenario where I will get a number which is greater than 5 and less than 10. I don't want that kind of number, means we'll just enclose it in a negation. And remember, there will be predictions also, like you just like BODMAS, you remember, brackets, we'll get this one later whenever we do some mathematical things. Okay, these are the operators. So for these programs we have done yesterday itself, like multiple, like arithmetic, addition, multiplication and everything. So we proceed with the second one, booleans. Any doubts so far here? Okay, we'll go to the next one. So I'm going like briefly I'm covering. So to get more information, please go through the material with that which I have provided. Boolean is nothing but true and false. So to use Boolean in C language, the data type of the Boolean is bool. It should be small case letter only, either true or false. And we cannot directly use bool in C language. Others we have many libraries, but in C there are only limited libraries. So to use inbuilt libraries, it's not like a inbuilt. So we have to add the preprocessor directive whenever we are using Boolean. That's nothing but hash include we use stdio.h for standard input and output, like printf and scanf. If we are using, we use stdio.h. And math.h, whenever we are using mathematical operations like square root, floor, seal, like this, we will use math. That for boolean we use standard boolean dot h. Okay. So those are the booleans. And now the main topic of it is like if else conditions. So whenever we are traveling on a road, so think we are from Vijayawada to Nellore. If you are coming, it's not a straight road, right? So in between we go like this. There will be like Ongole, Chirala, like that. Many villages or many towns will be there. So the highway will be like this. In between, it can be like going in between like this. Okay. So now if you are traveling from a car from here to here, so if you want to eat something in Ongole, so here there will be some signboard. Here, if you go to Ongole, if you go to straight, it will be Nellore. There will be some more stations will be there. So now here, if you have some relatives in Ongole, if you want to go to Ongole, then you have to make a decision here, but based on some condition. Your parents may ask, okay, anyhow we are going, right? We'll just go from there and then go. We can continue. On that based on condition, you go here. If this condition, if they said no, we will go directly, then we go directly here. So there is a decision that we can make here. And the same time here also. Some another destination. And like if we want to go to beach. So like this, based on condition, we have to check whether we want to proceed or not. So like this, if you want to in a program flow, if you want to execute a particular section based on a condition, then we will use if and else. If you don't want to execute that particular piece of code in our program, then we so usually if you see in a C language, everything is like top to bottom. So from main, your program execution will start. Whatever statements here you have, everything will be executed by the compiler. Okay. But if you don't want to execute these particular tasks, you want to execute these particular statements only based on some condition. Then only if you want to proceed to execute those particular statements, you need some mechanism in your program that which makes it possible. To make that possible, we have if and else conditions. If one condition is matching, then only you will enter into these blocks. Then only these statements will get executed. If else, if this condition is not matching, then these conditions, these statements won't get executed. You have else block. If this condition is not matching, you go and execute different statements like this. Or you have some more conditions that which you want to execute based on multiple conditions. So you will give condition 1. You give your statements that which you want to get executed. And again you have another statements also. Another condition also we have which you want to check. Then we have else if condition. So if you write so why we need else if? See here I have if condition. If condition is matching, I will execute these statements. And I will write one more if condition. You can tell like that. Statements, statements. But I don't want to execute this condition at all if it is matching here itself. If condition 1 is matching, I don't want to execute another condition 2. In those scenarios, we can use else if, which is like whichever is matching, that one only will get, those statements only will get executed. Apart from that, nothing will get executed. Okay. So these are all we will see in a program. Now I'm gonna write some programs for the topics that which we have covered. Let's come from the operators. So multiplications and everything we have done. So we missed something that I will cover now. We are gonna maximum. I am gonna use the online compiler only. My office laptop got logged. So initially I told like int x equal to 10 and int y equal to some 5. Okay. I want sum of this one. One way of doing it is like sum plus because we didn't give percentage d for this particular sum variable. That's why it is not printing. See, for this here, if you remember, I have given like this. So I can initialize like this or I can initialize like this also. In variable declaration and using them, we cannot use without declaring this particular value. Now, if I am using this one, here if you see there is some junk value is printing because it is printing the address value of it one of this particular variable because we haven't initialized it. So without initializing, if you use some variable, it will get the address of that particular variable. This is one of the rule. Okay. Now I want to check whether x is greater than or not by using another operators. So as I told earlier, we have to use /n escape sequences to print them in a lines, new lines. So x greater than y, x is 10 and y is 5. So we have the logical operator working, and we told like it will return, if it is true, it will return 1. If it is not true, it will return 0. This is it's like logical operators. And we have, we will check now if conditions. So now if you see, these all, every statement getting executed. I want to print sum if x is greater than y only. If you compare the earlier program with this one, so from main, the execution will should start and it will execute, it should execute from each line. But now if you see, let me check, let us do less than. If you see, printf is not working, this whatever statement we have, because x is not less than y. So if I tell like x is 10 and y is 5, which is not, x is not less than 5. So it will come here, it will check whether x is less than y or not. So it is false. So it is returning 0. And 0 is equal to 1 or not? No. We know that whenever it is true, then only it will return 1, else it will return 0. So here in this condition, it is returning 0. 0 equal to 1 or not? It's not. So it will exits from the pointer of execution will come out from this line. It will start from the 13th line. So remember, there will be a pointer running on. So the program execution always starts from main, and it will execute this program, is this line, and continuously it will keep on continuing. So whenever there is a condition in if condition, it will check here. So x less than y will return 1, 0, because x is not less than y. So 0 equal to 1. This one will be replaced in the data execution file with 0 equal to 1. So this will fail. So 0 is not equal to 1. So it will be false. So if condition is true, then only it will go inside this block. Else it will, the execution pointer will come out of that block and it will go and start executing from the next pointer. Okay. Like this, the flow of the programmatical flow will work. And now, so now x less than y equal to, then I am executing some work. And if x equal to y, then also I wanted to do some work. Then as we told, else if I want to check multiple conditions, if nothing, if nothing is matching, then I want to print no numbers are matching. So now the program pointer. So the execution flow will start from here. These lines will be executed. And here we have encountered with if condition. So if x less than or y or not, it will check. So it is not matching. So it won't execute this particular block. And then another condition is there, else if this condition is matching, yes, this condition is matching, you go inside, print this particular statement, come out of this loop, come out the. So here if else like this ladder, we call it as if else ladder. Okay, whenever there is a condition match, then that condition only that particular condition only will be get matched, will be executed, and then it will come out of that particular if else ladder, and then it will start executing. So basically it will be like this: if condition 1, the block of statements, else if condition 2, block of statements, else if condition 3, its block, and else. So else block will be executed when there is no match in this entire ladder. If there is no match, then only else block will get executed. So these are the conditions of the if else ladder. So now if we see, there are some limitations here. We can match only one condition at a time, and if nothing is matching, then only the last else block will be executed. So sometimes I want, even though this condition 1 matching and condition 2 matching, then what we can do, we can write it something like this: if condition 1 and condition 2 is matching, then you execute this statements. Else if condition 3 and condition 4 is matching, then you execute this particular statements like that, and else. So is there any better way to match more based on one condition? Yes, we have. We call it as a switch statement. In exam, you will get a question asking that define differences between if else and switch, and write a program for that one. Okay. Now let's check syntax of if. The syntax of if else is like if condition. For switch, it will be like here we, instead of if else conditions, here we have a case. So if whatever we are passing in this expression, whether that is matching with this or not, and your code block, whatever code you want to execute, and break is must. So in if else conditions, we have opening and closing brackets. So whatever in between, those will be executed and it will come out of. So in case after this one, this colon, whatever statements you have written, it will executed. To come out of that one, to come out of this block, you have to mention, you have to give a break, then only it will come out. And one thing which is missing in if else if condition is like, so it will get executed only if a condition is matching. If no condition is matching, then only else block will be executed. It's not default. If nothing is matching in the entire if else ladder, then only the else block will be executed. But I have a requirement where if nothing is matching, even though any of the thing is matching, like if condition 1 also matching, then also I wanted to have some expression or value to get executed. In those scenarios, we cannot give in if else, but we can give a default in in switch case. So in default, if you didn't write break also, not an issue, because it anyhow it will get exited from that one. Okay. Now we'll write a program for this one, for switch statement. So we can write for days. The syntax is expression. So what we want to pass here? So here I am passing day, and then open close braces. So I wanted to define case 1, which is we call it as Monday. And then there should be a break statement. And everyone's favorite Sunday. Okay. So 4 is now we'll see how the program execution will start. So whenever we compile and run this program, the program execution will start from main, and it will declare this variable in memory, and it will initialize that with 4, and it will go into the next statement. So here day is 4. Now here this will be replaced with 4. It will check case 1 whether 1 is equal to 4 or not. It's not matching. So it will go into the next case. It is also not matching. It will go into the next case. It is also not matching. So it is matching here. So here it's matching with 4, whatever we have supplied, and it is printing Thursday. And then it is coming out of it. So what if I write multiple, like 1 I already declared here. What if I write one more time? How it will take care? It doesn't allow, because we cannot give duplicate cases. So every, like in if condition, I think we can give multiple same cases. Like if I can give any number of times, but in case it doesn't, in switch it doesn't allow. We should define one condition only one time. By this, it will be like more precise. We know what condition we gave. So we cannot give duplicates here. We can define one case at a time only once. And what happens if I didn't give break? Because it didn't, let me give another example. It is coming from Thursday. So I didn't give Thursday break over Thursday. It printed Thursday and as well as Friday. Why? Why it printed Thursday and Friday? So as I told, the program execution will start from here. So all these cases are not matched. So here the case before the case matched here in 4 case match, it printed this one and it encountered with break and it exit from the switch statement. If there is no break statement here, it will continue, keep on continuing to the, it will check with the next case also. Even though it didn't match, it will get executed. Okay. So we have to write break statement compulsorily. If we didn't mean, if we didn't write a break statement, it will treat, okay, I want to execute next statement also. So break is a must, and there can be some scenarios where I want to for multiple cases I want to execute like R. This can be like R. So even if it is case when case 4 is R, when case 5, it this simply in if condition it can be treated as like this, like x less than 5 or x greater than 5. The same scenario in case it will be like case 5 without break statement, and case one more, case 6. So whenever like until there is it didn't encounter a break, it doesn't come out of the switch statement. And whenever the matching condition is there, then only it will print. So like if I give like some 10, nothing is printed. But if I give 1, it came into this case 1, this print, it will do the print and it encountered the break, it will come out of the switch. So to come out of the switch, we have to give break statement. So if we didn't give break statement, like from 4, there is no break statement from Thursday, Friday we have. Let me remove this one also. From, and again I have on break 7. Like let me give now 4. If you see until Sunday, it worked. So now here I have one more scenario, default. Okay. So after last, if you want to execute, as I told, if you give break, if it encountered a break statement, then it will exit. If you didn't give break, then the default one will be executed. So this is if and switch statement. You might get an question in examination, distinguish between if else and switch case statements. So you go through the material and then you will get more information on that one. So here now one problem I have, like every time I have to here I am changing, like 5 I am 6 I want to check. What if I want to make it dynamic? So like I have day, so instead of hard coding it, we have another scenario which we call user input. If a user want to provide some input, what he can do? So we have for that scanf. Which kind of data you want? I'm expecting an integer, so I will give /t, and what is the variable of that particular? So I should give an ampersand. Ampersand is nothing but the address. in which address I want to you want me to store, like that it will ask. So we have to provide the address variable of that one and the variable. So whenever a user gives the input, it will take that input value and it will assign that particular value into the address of this variable. Okay. So it is asking me, if you see the mouse, the cursor is blinking. So it is asking me a number. So I will give 1 and enter. It gives me Monday. So again I will I will give 5, Friday, 2, Tuesday. Yep. Hello. Okay. So these are the statements, if and switch statements and loops. I think we have discussed yesterday. So until now, whatever we have discussed, based on that, we will do programs tomorrow. Okay. Any doubts so far? Let me stop share.
No, sir.
So from tomorrow onwards, it will be like half session. We will discuss things, and then like remaining half, we will do more on programs. And we have some more basic things. From Monday we will do like that. We have some more things to cover. We have functions and structures and enums, that which still pointers and memory address, like dynamic memory allocation, how we do in C. So in Java, dynamic memory allocation is not required. Like there is a JVM will be there and it has garbage collector. It will take care of memory allocation and deallocation. But in C, we have to manually allocate memory for that one and deallocate memory. Okay. So those things, if permits tomorrow, we'll check tomorrow, and we will check functions, structures, like that. So there is one more thing here. I just want to we have some more time. So now in this entire program, I want to define a particular variable which doesn't change. It doesn't allow like some const like some final value. Like so now if you see here, the same value I can update with a different value. In whenever we are writing some programs, we don't want to get up those numbers to be updated. By that, our logic may change. So now if you see here, if I print this one, So initially the program executor came here, it assigned a day with 10 and it printed the value and it went into this one. So now the day value is 20. So it updated. So now the day value is 20. I don't want to get updated like this. So I want to make it by accidentally it can happen. I want to make it final. By that in the entire code block, the value of this particular value won't get changed. To make it, we have a keyword called constant. So whenever I define like this, it doesn't allow me to change that particular value. It is a read-only variable. So you cannot modify a read-only variable. So now the executor will take out the write permission for this variable from this code block. Okay. So by that now here I will get, it doesn't allow me to change this particular value here. So and it should be always initialized in the same statement only. If I try to initialize from below, it also doesn't allow. So constant value always should be declared in the same line in C language. In other languages, it will be different. So where we can use like this kind of constant, like I can tell like some we have pi value, right? Pi value doesn't change. We can define a constant pi value like this, and we can use all these variable in our program, like whenever we are calculating a circle area like that time we can use this constant over there. Okay, and there is some global variables also which we declared initially. I think if we give it here, it is used like whichever we declare in between these curly braces, right? That is local to that particular section only. Apart from this, we cannot utilize those variables. These variables we call it as local variables, whichever declared inside a block. Whichever declared outside the block, we call it as a global variable. This initially, if you remember, we declared some syntax like preprocessor directives, global variables, main section, and the statements, and the close brackets. And here we can define some structure that we will check tomorrow. Okay, that's it from now. We can discuss more on tomorrow. If anything else, any doubts you have, we can ask me. Okay, then we'll meet tomorrow. Bye.